So in this lesson today, we're going to talk about what is similarity, and we're going to talk about transformations with dilations, okay? So the term similar means that two figures are similar if they have the same shape, but they're not necessarily the same size. So, and the similar symbol is, looks like this. So it's kind of like the top part of the congruent symbol, only it doesn't have the equal sign underneath it. So similar polygons are two polygons whose corresponding angles are congruent and whose corresponding side lengths are proportional. So that means, for example, if we had a drawing like this, two triangles, right? And I told you all this side was 1 and this side was 2. And I said A, B, C, and D, E, F. We would write the statement triangle A, B, C is similar to triangle D, E, F. And they're proportional because this means that the A would be congruent with D, and B would be congruent with E angle-wise, and C would be congruent with F. And then we could also say that the sides are proportional. So let's say all of these sides were 1, 1, 1, and all of these sides were 2, 2, 2. Then we know that triangle DEF is 2 times the size of triangle ABC, right? So a similarity ratio is the ratio of two corresponding linear measurements in a pair of similar figures. So if we were going from ABC to DEF, it would be 2 to 1, which would be 2 over 1, right? Or if we were going from DEF to ABC, then it would be 1/2, right? Because it would be getting smaller. So it would be a 1 to 2 ratio, okay? Similarity statement is a statement that indicates that two polygons are similar by listing their vertices in the order of correspondence like I did up here, okay? Similarity transformation is a transformation that produces similar figures. Now, a transformation that produces similar figures is similarity transformation. So similarity transformation is a dilation or a composite of one or more dilations and one or more congruence transformations. So that basically means translation, reflection, rotation. So two figures are similar if and only if there is a similarity transformation that maps one figure to the other figure. So that again would be a rotation, a reflection, a translation, and then also a dilation. So the dilation is a transformation that maps one image to another. Okay, so that maps, pause. I knew something was missing. So y'all, this maps KXY to KX, where the center of dilation is 0, 0. So let me fix that as well. Let's see if I can do that here. 0, 0, like it is in your notes, okay? So if the dilation is between 0 and 1, then obviously it's a reduction because that means that that's a number, that's either a decimal or a fraction, right? If k is greater than 1, then the dilation is an enlargement. So let's say that was 1.5 or 2 or 2.5, whatever, okay? So whatever that is, if it's bigger than 1, it's obviously an enlargement, okay? So remember that translations, reflections, and rotations are congruence transformations. That means that they are they produce an image that is the exact same size, whereas when we dilate it, it gets bigger or smaller, okay? So here's our first one, example 1a. It says, apply the dilation D to the polygon with the given vertices, describe the dilation. So what we're going to do when we have a dilation of, like it says here, x, y, and then it's going to go to 3x, 3y, we're going to multiply 3 times every one of the numbers. So we're going to multiply 3 times 1 there, so that's going to be 3. 3 times 1 again there, so that's going to be 3. 3 times 3, so that's going to be 9. 3 times 1, that's going to be 3. 3 times 3, that's going to be 9, and 3 times 2, so that's going to be 6, okay? So now we're going to plot these new points, 3, 3. 3, 3's right there, so that's our new A prime. 9, 3 is right there, so that's going to be, sorry, I don't know why I did that, that's supposed to be a B. 9, 3 right there is B. And then C is 9, 6, so 9, 6 is up here. So this is our C, so now we can go ahead and connect those dots. So this is the dilation, and it's moving away from the origin, right? And it should if it's a dilation from the origin, okay? And notice this side's 2, and so this side is 1, 2, 3, 4, 5, 6, and 2 times 3 is 6. This side is 1, and this side is 3. 1, 2, 3. So that's another way that we can check to see what the dilation is, okay? So let's do another one just for practice, okay? So this one says apply the dilation D to this. So that was, by the way, an enlargement, right? This was an enlargement, okay? This next one we can tell, because this is 3/4, that this is going to be a reduction, right? So it's going to get smaller. So what we're going to do is, again, we're going to go -8 times our 3/4 and see what number that is. That gives us -6, right? Then we're going to go 4 times 3/4, and that gives us 3. You guys can do this in your calculator, right? So now notice that we have a -4, so that's just going to be a -3, isn't it? Okay, and we have an 8. We had a -8 before, so this is going to be a 6. Then we just have 2 4s, right? So we've already done a 4, so this is going to be 3 and 3, okay? So because we have the same numbers repeated just with a negative in them or not, that's how we're going to change the sign. So now we're going to plot this one. P prime, Q prime, R prime. So P prime is at -6, 3, 1, 2, 3 right there. So that's our P prime. Then we've got Q prime is at -3, 6. So that is right there, Q prime. And we've got R prime is at, where is that at? 3, 3. So 3, 3 is right there. So that's our R prime, okay? So this one's a little harder to be able to tell the change, right? So we're going to actually count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the new one is 9. And the original one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to be 9 over 12. We're always going to take the number of the new side and put it over the number of the old side, because that's going to show us. Now this reduces to be what? 3/4. You got it. And that's exactly what our reduction was. Okay, so this next one says apply the dilation 1/4. So we know this time again it's going to get smaller, right? So don't we just have to divide all those numbers by 4 this time? Divide that by 4, divide that by 4, divide this by 4, because that's the same thing as multiplying by 1/4, right? So we're just going to divide all those numbers by 4. So that's going to give us -2, 0, -2, -1, -1, and -2. So we're going to plot these points now. So that's going to give us D prime at -2, 0 right there. That's our D prime. And -2, -1 is going to be right there. That's going to be our E prime. And -1, -2 is right there. Ooh, this is a little teeny tiny triangle, isn't it, y'all? So that's our triangle right there, y'all. It's literally teeny, teeny, tiny. Oops, wait, did I do something wrong? Oh, I did. I was supposed to go down to -2. It didn't look right. Okay, let's plot it again. -2, 0 there. -2, -1 there. And then we've got -1, -2 down there. It didn't slant like I thought it was going to. So that side's straight up. So let's just count this side. 1, 2, 3, 4. So that goes on the bottom, remember. And this one's 1. So that one goes on the top. So that is exactly the ratio that we expected. Okay? Now this is going to be applicable to this next part. Okay? So this is important that you guys can see this. So we're going to go ahead and draw this shape A, B, C, D. A, B, C, D. We're going to close this. This is a, I don't know whether that's a rectangle or square. Y'all would have to count the sides. But this one's saying determine whether the polygon with the given vertices are similar. So what we want to do is see if we can come up with a ratio. So we're going to compare some points. So y'all see these 2 points right here? So remember, we're going to take our original and we're going to put it on the bottom, and we're going to take our transformed and put it on the top. So what does that reduce to be? Well, obviously a negative over a negative makes a positive, and 2 goes into 6 3 times. So this is 1/3, right? So if we plot our new shape HJKL, we should see that this is a reduction. Okay, and if not, then we did something wrong. -2, -2, that's our H. Then -2, 1. -2, 1 is right there, that's J. Then we got 1, 1 right there, that's K. And then we got 1, -2 right there, and that's our L. Okay, So we're going to go ahead and connect these dots. And again, we see that this is, so let's count again our new 1, 2, 3. So that's 3. And let's count our original 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, we're taking our new and putting it on top and our old putting it on the bottom. And again, we got 1/3, didn't we? So yep, it was a reduction. It is similar, first of all, because every one of these is reduced. And then it's a dilation by a scale factor of 1/3. And the way we could write that is 1/3 of x, comma 1/3 of y, right? Okay. All right. So this next one, it's asking us again to see if these are similar. So let's go ahead. Now, also, by the way, it's always a good idea to go ahead and test every point just to see. Okay. So you can see the same ratio here. You can see the same ratio there. And then you see that, do you see the 3/1 here, the 3/1, the 3/1, the 3/1, the -6 over the -2? It's a good idea to check all the points to see if they are truly similar, every single point, because one might be off. And if one is off, then they are not going to be similar, okay? So on this next one, I went ahead and closed the shape here. And it says, again, so let's go ahead and compare these points, okay? So what I'm going to do this time is I'm going to take the new shape and I am going to go ahead and plot the points for it. So W is 5, 0. So that's my W right there. And then we've got 5, 10, which is up here. That's going to be my X. Then we've got 8, 10 up here, and that's my Y. And then, you know what, let's move the X to the outside. So that X is out there, and then we've got Z is at 8, 0 right there. So this is my, oops, I'm having a hard time drawing today, y'all. This is my new shape. And we're talking about dilations again from the origin, y'all, okay? So all of these dilations that we've been doing today have been from the origin, and that's kind of important because later we're going to do some dilations from points other than the origin. So, and this was Z. So you should be able to see again that this is 1, 2, and this is 1, 2, 3, right? And so if we're going from, we went 2, 3 from 2, right? So that would be 3/2. That'd be 1.5. So let's double check this one. 1, 2, 3, 4. We started with 4, right? So remember that goes on the bottom. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the question is, are those the same ratio? They don't look like the same ratio to me, and that's just comparing sides. But now we're going to compare a couple points, okay? So let's go ahead and compare the 2 and the 5. Okay, so that would be 5/2, right? 5/2. And that's what this would reduce to be, yes? But if we keep going, notice here we have, let's see, what else do we have? 5/2, 5/2, 10/4. Ooh, look at this one right here, Y and R. So on this one, we have an 8/4, and this one we have a 10/4. So this 8/4, is that the same ratio, y'all? 8/4 is what ratio? Isn't that 2/1? Okay, and here again, we have the ratio 8/4. So because we didn't get the same ratio for all the values, which is why I said in the previous one we should check all the points. And even when we compared these sides, here we had 4 and there we had 10, right? That was our 5/2 ratio, right? But when we checked these sides, we had 2 and it was 3 wide here. So they did not dilate the same amount on the various sides. So that was a hint to us that these are not similar, y'all, okay? Because if they were, we would have the same ratio on both sides, okay? So let's go ahead and let you guys do these U-tries. Come back to me when you're done. So here again, I'm going to go ahead and plot STUV. S is at -1, 1 right there. T is at -1, 2 right there. Ooh, that's really small. U is at -3, 1 right there. And V was at -3, -1 right there. So this is one tall, and there we go there. Okay, so y'all see that? So this one definitely looks like, again, if we count 1, 2, 3 versus 1, right? So we are going 1 over 3. Let's count this other side. 1, 2, 3, 4, 5, 6. So remember that 6 goes on the bottom. And 1, 2. So does that reduce to be 1/3? Sure does. Okay, so now let's also check with our points, okay? So here again, we're going to go look at the ratio. 3 over -1, okay? 3 over 1. So, and then we've got 3 over -1 and 2 over 6, 9 over -3. So it says determine whether polygons are similar, okay? So now this one, the challenge with this one is it looks to me like this one has a reflection, y'all, and then it dilates. Is that what it looks like to y'all? So did you guys notice the short side here and the short side there and the long side there and the long side there? So I would say that this was a reflection over the y-axis, and then it dilated by what? By 1/3. Okay, so that means it would be 1/3 x, comma 1/3 y. Okay, so let's just try that. Let's go ahead and take these points 3, 3, and let's reflect them. So if this point F, if we did an F prime, for example, if we did an F prime and we reflected it over the y-axis, it would be -3, comma 3, right? And then if we looked at our S then, our S would be -1, 1. Now do you notice that that's the right point? If we continued with the G, it would be -3, -9, -9, right? All of those would become negative because we're flipping it over the y-axis and then dilating it, right? So that's why this works, okay? So now let's look at this next one. P is at 3, 6. 3, 6, 3, 1, 2, 3, 6, right there. That's P. Okay, pen, work for me, please. Okay, then we got Q, which is at 3, 9. Well, I definitely didn't put that in the right place, did I, y'all? 3, 9. 3, 9 is right there, and that's our Q. And then we're at 12, 9. So 12, 9's right there, and that's our R, okay? Okay, so let's look at this. So if we look at this side, which is obviously the PQ, that's our shortest side, right? So here it's 3, and there it's 1. Okay, so our original, so that would mean that it's getting 3 times bigger, right? So we're going to compare that, but it looks to me also like it's a rotation, doesn't it, y'all? Do y'all see that this side right here, that AB becomes PQ? Can y'all see that right there? Okay. And we could also count this one. So this is 1, 2, 3. That's a straight side. And it becomes, okay, that was 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And so that got 3 times bigger as well, didn't it? So I'm pretty sure we have a scale factor of 3x, comma 3y, right? But we also want to rotate it. So look at the original image. Where did it rotate? It went from quadrant 4 to quadrant 1, right? So wouldn't that be a 90-degree rotation? Okay, so what's that rule? Y'all remember that rule? -y, comma x, right? So let's see if that happens. So let's look at our point here. So we're at 2, 1. So let's do an A prime. We're going to apply that rule. So that means it would be -1, comma, well, actually, it'd end up being a +1, wouldn't it? Because you changed the sign. So it'd be 1, comma 2. Now, if we multiplied that by 3, that would be 3, 6, wouldn't it? So that's what gave us that P. Y'all see it? So On this one is a 90-degree rotation. And then what? A dilation by a scale factor of what? Dilation by 3. Right? Okay.